Welcome to MRL. In this learning session, we'll learn about a very important topic in mathematics, that is trigonometry. Now, what is trigonometry? Trigonometry means tri means 3, gono means sides, metro means measure. So, trigonometry means a process of measuring the three sides of a triangle. But trigonometry can be defined as a branch of mathematics which deals with the study of relationships between the sides and angles of a triangle, in particular a right triangle. Now, trigonometry can be used, it has its own application. Trigonometry is used to measure heights and distances which are not easily measured or accessed. Trigonometric concepts are used in engineering and physical sciences. For example, we can find the height of a Qutub Minar, which is otherwise difficult to measure the height. We can measure it with the help of trigonometry. And so also the width of the river, height of a hill, and all those which are not easily accessed can be measured with the help of trigonometry. Remember that. Now, before we proceed with the study of trigonometry, let us understand a few important basics. For example, what is a right triangle? We already know a triangle in which one of the angle is a right angle is a right triangle. So, triangle ABC is a right triangle because angle B is 90 degrees and therefore ABC is a right triangle. Now, angle A plus angle C, if you see angle A and angle C, the sum of these two angles is 90 degrees. We say angle A and angle C are complementary angles, and also angle A and angle C are acute angles because both of them are less than 90 degrees. Remember that. Now, naming the sides of a right triangle. We have a triangle ABC here. Now, we have to learn how to name the sides. It means the naming is very important as far as trigonometry is concerned. Now, angle B is 90 degrees. We can and angle A and angle C, as we know, they are complementary angles. Angle A and angle C are also acute. Now, naming depends on which angle you would consider. Now, let us, if I take angle A, if with respect to angle A, then AC as it is hypotenuse with respect to angle A, BC is opposite side and AB is adjacent side. This AB is adjacent to this angle and BC is opposite to this angle. Remember that. So, therefore, I have written here AC is hypotenuse, BC is opposite to angle A and is opposite side, and AB is adjacent to angle A and is adjacent side. And also, you know about the Pythagoras theorem, that is AC square is equal to AB square plus BC square. Now, naming the triangle, the sides of the triangle with respect to angle C. Now, if I take angle C, AC is hypotenuse as it is, the side BC is adjacent to angle C, therefore it is adjacent side, and side AB is opposite to angle C and therefore it is the opposite side. So, please remember the naming of the sides of a right angle triangle with respect to the two acute angles. Now, coming to the meaning of ratio. Comparison of two quantities of the same kind and in same units is called a ratio. And if ratios are equal, then we say they are proportional. So, therefore, now the ratio can be of numbers, lengths, areas, etc. Remember that. In trigonometry, we have to define trigonometric ratios. The ratios involving the sides of a right triangle with respect to an acute angle are called trigonometric ratios. Again, I will repeat, the ratios involving the sides of a right triangle with respect to an acute angle are called trigonometric ratios. Now, the trigonometric ratios express the relationship between the lengths of the sides of a right triangle and one of the acute angles of a right triangle. Again, I will repeat, trigonometric ratios express the relationship between the lengths of the sides of a triangle with respect to one of the acute angles. Remember that. Now, we can define 6 trigonometric ratios because in a right angle triangle there are 3 sides and therefore we can have 6 ratios. That means A upon C is one ratio, then C upon A is the second ratio, B upon C is one ratio, C upon B is the another ratio, and so also we have A upon B is one ratio and B upon A is another ratio. Therefore, in a right angle triangle, because we have 3 sides, 6 ratios are possible with respect to any acute angle, whether it's acute angle A or acute angle C, and those 6 ratios are A upon C, as I have already told you. These are the 6 ratios. Remember that. Now, in trigonometry again, these 6 ratios are having their own importance and they are defined. Now, for example, let us take the 6 trigonometric ratios. Let us understand what they are. Now, with respect to angle A, the sine of angle A, we can call it as sine of angle A, sine SINE. This is the first trigonometric ratio, sine of angle A with respect to angle A. Sine of angle A is equal to opposite side, that is opposite side is BC upon hypotenuse AC. So that is what is the definition of the sine ratio in trigonometry. So sine of any acute angle A is equal to opposite side upon hypotenuse, and that is equal to BC upon AC. The second important trigonometric ratio is cosine of angle A or cosine A, that is equal to adjacent side upon hypotenuse, that is AB upon AC. Then the third important trigonometric ratio is tangent of angle A or tangent A, and that is equal to opposite side upon adjacent side, opposite side upon adjacent side, and that is BC upon AB. Mind you, I am defining these ratios with respect to acute angle A. Now coming to the next important ratio, that is cosecant of angle A or cosecant A, and that is equal to hypotenuse upon opposite side, that is equal to AC upon BC. Secant of angle A is the next trigonometric ratio, or secant A, that is hypotenuse upon adjacent side, and that is equal to AC upon AB. And cotangent of angle A or cotangent A is equal to adjacent side upon opposite side, that is AB upon BC. And very interestingly, the first three trigonometric ratios, sine of angle, sine A, cosine A, tangent A, if you see the ratios, they are reciprocals. Cosecant is the reciprocal of sine, secant is the reciprocal of sec, that is the cosec, that is cos, that is I have already written here, that is cosine, reciprocal of cosine, and the cotangent is reciprocal of the tangent here. So therefore in all we have 6 trigonometric ratios. Now the 6 trigonometric ratios, sine A, cosine A, tangent A, cosecant A, secant A, cotangent A, we have their abbreviations, that is sine SINE is written as SINA, cosine is written as cos A, tangent is written as tan A, cosecant is written as cosec A, secant is written as sec A, and cotangent is cot A. So in trigonometry we have these abbreviated names for the 6 trigonometric ratios, and in that the first 3, that is sine A, cos A, tan A, are primary T ratios, and cosec A, sec A, and cot A are the secondary trigonometric ratios. Remember that. Now sine A or sine of angle A, sine A or sine of angle A is defined as the ratio of opposite side to the hypotenuse of a right triangle for any acute angle A. So this is the definition of the trigonometric ratio, the first trigonometric ratio, that is sine with respect to an acute angle A. So we have to remember the definitions also. Now similarly other trigonometric ratios can be defined, so try to define them yourself. Now relation between the primary and secondary T ratios. We already know what are the primary T ratios, and we already know what are secondary T ratios. The primary T ratios are, trigonometric ratios are sine, cosine and tangent, that is sine, cos and tan, and the secondary T ratios are the cosec, sec and cot. So we have sin A here, sin A is equal to 1 upon cosec A. That means the primary and secondary T ratios are reciprocals of one another. That means if you take sin A, it is 1 upon cosec A, and if you take cosec A, it is 1 upon sin A. If you take cos A, it is 1 upon sec A. If you take sec A, it is 1 upon cos A. And if you take tan A, it is 1 upon cot A. And if you take cot A, it is 1 upon tan A. Now sin A into cosec A, the product of sin A into cosec A is 1, cos A into sec A is 1, tan A into cot A is 1. So please remember this. The product of sin A and its reciprocal is 1, cos A and its reciprocal is 1, tan A and its reciprocal is also 1. So these are very important relations which you have to remember. So therefore in all there are 6 trigonometric ratios. In that the first 3 are primary and the next 3 are secondary, and the primary T ratio and secondary ratios are reciprocals of one another. If you take the product of the reciprocals, then it is 1. Remember that. And also remember, sine of this is sin A does not mean it is a product of sine and A. No, it is not a product of sine A. It is a trigonometric ratio sine with respect to an acute angle A. And also sine raised to minus 1A is not equal to 1 upon sine A. It does not take, that is sine raised to minus 1A is not equal to 1 upon sine A. Sine raised to minus 1A is a inverse sine ratio which is studied in higher classes. Now sine A raised to 2, sine A square, that means sine A is multiplied 2 times, it can be written as sine square A also. Sine A whole to square or sine square A mean the same. Remember that. Now the relation between sin A, cos A and tan A. So let us understand this. Now let us consider the triangle ABC. Now sin A is equal to sine of angle A, or you can even take theta here. Sine of angle A is equal to BC upon AC, because it is opposite side upon hypotenuse. Now cos A is equal to adjacent side upon hypotenuse, and that is AB upon AC. Okay, and the tan A is equal to BC upon AB, that is opposite side upon the adjacent side. So these are the three definitions. By definition we have sin A is equal to BC by AC, cos A is equal to AB by AC, tan A is equal to BC by AB. And very interestingly, if you take sin A and divide it by cos A, that means take BC by AC divided by cos A, AB by AC, AC will cancel, we get BC by AB, and BC by AB is nothing but tan A, and therefore the relation between tan A, sin A, cos A is tan A is equal to the ratio of sin A by cos A. Tan A is equal to ratio of sin A by cos A, so we say tan A is equal to sin A by cos A. Now the relation between sin A, cos A and cot A, again by definition we have sin A is equal to BC by AC, cos A is equal to AB by AC, cot A is equal to AB by BC, and if you take the ratio of cos A by sin A, we'll get AB by BC, AB by AC divided by BC by AC, AC will cancel, we get AB by BC, and AB by BC is cot A, and therefore cot A is equal to cos A by sin A. Remember, cot A is equal to cos A by sin A, cot, cos, that is how we remember. Cot A is cos A by sin A, tan A is sin A by cos A, and very important relation. And also you know tan A and cot A are reciprocals, and therefore if I take the reciprocal of sin A by cos A, I get cos A by sin A. So that is how we remember it. Now the values of T ratios. Values of T ratios are independent of the measure of lengths of sides of a triangle. Remember this, the values of T ratios are independent of the measure of the length of the sides of a triangle. The length of the measures of the sides of a triangle has got nothing to do with the values of trigonometric ratios. So but it all definitely depends on the angle. So the value of T ratios depend on the angle A, that is acute angle A or at acute angle C. It does not depend on the lengths of the side. Let the length be of any size, the ratio value will be the same, it will not change. Now the very important example here to understand, to given value of T ratio, you are given a value of T ratio to find the values of other T ratios. What is the same example? Let us understand. Now we are given given sin A is equal to 1 upon 3. Already we are given sin A is equal to 1 upon 3. This is a ratio given to us because we know what is sin A, and the ratio is 1 upon 3. Now we are asked to find out the values of other trigonometric ratios. Let us understand this. Now in triangle ABC, sin A is equal to 1 by 3. Sin A is equal to 1 by 3 means what? Opposite side upon hypotenuse is 1 upon 3, therefore BC is 1 and AC is 3. Now in triangle ABC, by applying Pythagoras theorem, we can find AB. That means AB square is equal to AC square minus BC square. That means that is 9 minus 1, and that is 8. Therefore AB is equal to root 8 or 2 root 2. So we have found out AB. Now once we know BC, once we know AC, and once we know AB, very easily we can write all the values of trigonometric ratios by their definition. Sin A already we know it is 1 by 3. Now let us talk about cos A. Cos A is 2 root 2 by 3. So it is 2 root 2 by 3. That is cos A. Cos A is 2 root 2 by 3. Tan A will be 1 upon 2 root 2 because BC upon AB is tan A, and therefore it is 1 by 2 root 2. Now cosec A will be the reciprocal of sine, and therefore it is 1 by sin A, and therefore 1 by 3 becomes 3 by 1, therefore 3. Sec A is the reciprocal of cos, and therefore sec A is equal to the reciprocal of 2 root 2 by 3, that is 3 divided by 2 root 2, and cot A is the reciprocal of tan, and it is 2 root 2. So therefore, given one value of trigonometric ratio, we can find out all the other values by a very simple method, and this is the simple method of finding out those values. So remember this much. In the next learning session, we'll continue learning the remaining aspects of the trigonometry. Thank you.